Hello, my name is Varun. So in this talk, I will be defining some algebraic properties about complex numbers. So let's get to it. So what do I say when I mean by algebraic properties? Let's say addition, multiplication. First, let's see how these both can be done. Let Z1 be A1 plus IB1, Z2 is A2 plus IB2. These are the representations of Z1 and Z2. So now what will Z1 plus Z2 be? Yeah, so you guessed it right. It will be A1 plus A2 plus I times B1 plus B2. Because see, the real parts get added just like that. Well, the imaginary parts, I gets taken in common and then B1 plus B2. So this distributes. And this gives us the complex number A1 plus A2 plus I times B1 plus B2. What about multiplication? Multiplication is more interesting. Z1 times Z2. This is equal to A1 plus IB1 times A2 plus IB2. Well, this is nothing but A1 A2 plus A1 into IB2 plus IB1 into A2 plus I square B1 B2. Yeah, but I square is equal to minus 1. So this is nothing but A1 A2 plus I times, now I take A1 B2 and B1 A2 inside this bracket because they are both multiplied by I. Okay, so this is I times A1 B2 plus B1 A2 minus B1 B2. Why? Because I square is equal to minus 1. I was root minus 1, remember? So here is where the property of I actually comes into picture. This is nothing but A1 A2 minus B1 B2. You see, this is a real number. A1 and A2 are both real numbers. B1 and B2 are also both real numbers. They are only multiplied by this I coordinate. Okay, so this is A1 A2 minus B1 B2. I bring the B1 B2 from here to here plus I into A1 B2 plus A2 B1. So this is multiplication. First we had addition, then we had multiplication. Now let's move on to subtraction. Subtraction is just the addition of, so Z1 minus Z2 is just Z1 plus minus Z2. This is nothing but minus Z2 is nothing but minus A2 plus minus IB2. So this is nothing. So subtraction can be done. I mean, and in fact it comes out to be A1 minus A2 plus I into B1 minus B2. Now let's come to division. We want to find out what Z1 divided by Z2 is, where as usual Z1 is equal to A1 plus IB1 and Z2 is equal to A2 plus IB2. But we know that division can only be done when the denominator is non-zero. So Z2 is not equal to 0, which means Z2 is not equal to 0 plus 0i, which means this A2 comma B2 is not equal to 0 comma 0. What does this mean? This means that A2 and B2 cannot both be 0. At least one of them has to be non-zero. It's possible that both of them are non-zero, but both of them cannot be 0 at the same time. So what is Z1 divided by Z2? Z1 by Z2 is A1 plus IB1 divided by A2 plus IB2. Now I'm not going to explain the whole division process here. In fact, I'm going to leave it to you as an exercise. However, I will give one hint though. The hint is that you look at this expression. Now multiplying the numerator and denominator by any non-zero number is not going to change anything. They are just going to get cancelled out. So let's multiply this by, let's say z. Z is some number which you have to figure out what it is. I'll explain why. Now you have to multiply this with a number z such that A2 plus IB2 times z, okay, that is the new denominator, somehow becomes a real number. So what happens if this is accomplished? If this is accomplished, then you will have A1 plus IB1 times some complex number divided by a real number. Now this you can write down because you know multiplication of complex numbers. This will be A plus I times B for some capital A and B real numbers over some real number, correct? And this real number is non-zero, you have to ensure that. But if you do this, then you already know how to multiply, and so you will get A plus IB divided by some real number which is equal to some complex number. So this is a hint that you have to choose a clever number such that the denominator a2 plus ib2 times z, when you actually carry out the multiplication, the imaginary part becomes 0, or it just goes away, and so only the real part is left. And this I will leave it for you to figure out. Okay, thank you.